I want to introduce you to a visual I made to help you understand pedagogy, or the methods of teaching, as a spectrum of practices. In special education, we focus a lot on explicit instruction as an efficient and effective method for teaching the mastery of specific skills. This pedagogical approach is appropriate for learning procedures and for emergent understanding of concepts. To really deepen conceptual understanding and expand critical thinking opportunities, we need to flexibly utilize different pedagogies based on the goal of instruction and the student's level of knowledge. To determine the most appropriate pedagogy to use to match your instructional goals and the needs of your learners, you need to understand a bit about learning theory. There are many learning theories, but we are going to focus on 3 that have a major impact on pedagogy. The lines between these theories are not rigid. Though some teachers and scholars may have a stronger belief in one theory over another, teachers can actually draw upon multiple learning theories depending on the situation. First, let's focus on behaviorism. Behaviorism is the belief that learning results in an observable change in behavior. Environmental stimuli cause a response from the learner. The learning or behavioral response pattern is repeated and reinforced to become automatic and generalized. Some instructional approaches that draw upon behaviorism are using affirmative and corrective feedback, or using other verbal reinforcements and praise. We could do rote practice of skills, mastery learning, and establishing clear rules and expectations. Some considerations for leveraging behaviorism learning theory is that these applications are effective for knowledge recall or teaching new skills or procedures, but they are less effective for problem solving, critical thinking, and innovation. This learning theory is leveraged most often to support students with the most intensive support needs. Next, let's discuss cognitivism. Cognitivists believe learning occurs through the cognitive processing of information. They see behavioral changes as an observable sign that there have been changes in mental processes. Through the lens of cognitivism, learning involves the reorganization or revision of current understandings as new information or insight is acquired. Some examples and applications of cognitivism would be using mnemonics to help the learner recall something, or providing scaffolds that help the learner reorganize their existing schema, like schema-based problem solving, using concept maps or other graphic organizers. We could also use explicit strategy instruction or provide visual imagery to help students understand concepts. Some considerations with cognitivist approaches are that some students may require differentiated levels of support to utilize different strategies. Teachers must consider students' prerequisite knowledge and the cognitive demands of the tasks to provide appropriate scaffolds and supports. Last, we will discuss constructivism. Constructivists can be broken into what we call social constructivists like Vygotsky, or cognitive constructivists like Piaget or Brunner. Each theorist has different components within their own learning theories, but we are going to talk about some general beliefs among constructivists. Constructivism is very popular in general education, particularly in STEM fields. Constructivists believe learning involves the construction of knowledge based on interpretation of one's experiences. In other words, learning involves reflection on current understandings and then making adjustments to accommodate new experiences. Examples of constructivism in action include students doing research projects, problem or project-based learning, simulations or role-playing, case studies, and other forms of social learning. Some important considerations for constructivist pedagogy is that it does promote critical thinking and problem solving. However, it also requires that students have the sufficient background knowledge to construct those new understandings. Oftentimes, when learning is directed by the learner themselves, the learning outcomes can be unpredictable, especially without strong facilitation from an expert. Seeing these learning theories side by side, we can think about the learners to help us flexibly choose our teaching methods. The left side, where behaviorism is located, is often good for the novice learner as the new skills are being introduced, whereas the right side, where constructivism is located, is often better as the learner gains more expertise. Learning theories drive the pedagogy we choose. I want you to think about pedagogy as a spectrum that ranges from teacher-driven instruction to student-driven instruction. You may have heard of the phrases teacher-centered and student-centered to describe these same concepts. I'm going to encourage you to not use these terms because they imply that some pedagogies do not keep the learners as the focus. No good instruction is ever teacher-centered. In fact, systematic and explicit instruction that are often criticized by those who do not understand the pedagogy to be teacher-centered are in fact incredibly student-centered approaches. They are teacher-driven, though. The teacher has expertly crafted this type of instruction directly based on the assessment of student strengths and needs. The opposite end of this spectrum, where we have student-driven instruction, means the students are deciding what and how they are learning based on their own wonderments and interests. Let's briefly review some of the pedagogies listed on this spectrum. Similarly to the learning theories, there are many other pedagogies not present on this visual. In fact, many pedagogical approaches can fall at different places on this spectrum in one lesson. Flipped learning, for example, utilizes more explicit forms of instruction for at-home independent activities and more supported or problem-based activities during class time. All the way at the left of this spectrum, we have two of the most teacher-driven pedagogies, Engelmann's Big D direct instruction and systematic instruction. These pedagogies draw largely from behaviorist learning theories and are most often used to teach discrete skills to students with the most intensive support needs and to those who benefit from a lot of structure. Explicit instruction is also mostly teacher-driven, as the lesson structure is guided by the teacher to scaffold from modeling of the new skill or concept through guided and supported practice, and finally to independent practice and mastery. In the middle of the spectrum, we have a wide range of guided and supported activities that can have various teacher or student-driven structures. These could be lab-type activities or station activities that allow students to practice a skill in multiple ways. In math, for example, students could model operations with whole numbers using different kinds of manipulatives. For structured activities where the teacher would tell students the tools for modeling, that would fall towards the left side of this range. Whereas if the students were given more freedom to choose their tools, methods, and strategies for modeling and solving problems, that would fall more on the right side of this range. Oftentimes, teachers will differentiate these types of activities, moving back and forth in terms of levels of directives and the amount of support based on the student's needs. As we slide to the right of guided and supported activities, we have problem-based learning. This pedagogy is popular in math and STEM courses, but it could also be used in other content areas. Similarly to the right end of guided and supported activities, problem-based learning, or PBL, is more student-driven than teacher-driven. With this type of lesson, the teacher has crafted some kind of task that requires students to problem solve and think critically. This type of task should have multiple right approaches for solving and multiple correct solutions to the problem. Teachers can differentiate this type of lesson by offering more support, feedback, and strategies for some students, and more freedom or additional challenge components for other students. The teacher's role in PBL is to be the guide on the side, or the facilitator of learning, rather than the giver of information and skills. All the way to the right is what we would call authentic learning. This form of learning is entirely student-driven, and those who fall at the way end of this may utilize very little teacher support. An example of this would be a student conceptualized and planned research project where they identify the problem, they identify the methods used to investigate the problem, and they solve it themselves. Peer review and feedback is also common for this type of learning. Students need sufficient background knowledge and expertise to engage in true, authentic learning. Teachers can always provide additional supports, and make more directives for some students as a scaffold while the students are developing the skills and knowledge to be independently successful. In an ideal situation, we want most learning to be authentic learning. This is why we strive to move students to the right side of the spectrum. You might ask yourself, if authentic learning is our goal, why do we use other pedagogies? Remember, this spectrum also stretches from the novice to the expert learner. More explicit methods led by an expert teacher are highly efficient and effective ways to teach some content. You should always consider both the learner and the learning goal when choosing your teaching methods, and remember to stay flexible with the methods you choose. There are a few other pedagogical concepts I'd like to connect with this pedagogy spectrum visual. The first concept is discourse during a lesson, which is very important. I'm going to utilize Stein's 2007 levels of discourse for this explanation because they fit very well with this visual. Different pedagogies lend themselves to different levels of discourse. Level 0 discourse is when teachers ask questions that have a simple, short, correct answer, and then they offer immediate feedback. These types of questions are the only types used in systematic instruction and are also very common for direct and explicit instruction approaches. An example of level 0 questions would be, how many blocks do you see? Which of these pictures shows a car? Level 0 doesn't mean the students are not communicating, it just means they are not engaging in deep discourse. In one final note about student responses, it's important to note that students may not be verbal and may communicate through other alternative means, like through augmentative and alternative communication devices, or by physical gesture. These are still valid forms of discourse. Level 1 discourse is where the teacher asks direct questions about student thinking. The teacher is the elaborator in the situation, responding to some students' thinking, filling in gaps, and building on new ideas. Notice how explicit instruction falls partially over level 0 and partially over level 1 discourse. These are often the two types of discourse students engage in during explicit instruction, and those lines are not rigid. As instruction moves toward more guided and supported activities, the teacher is likely to utilize a combination of level 1 and level 2 discourse throughout the lesson. In level 2 discourse, the questions become more open-ended, meaning they have multiple correct responses. To truly engage in level 2 discourse, the teacher should facilitate the conversations, but allow the students to do more of the talking. So to reiterate, the teacher poses the question, and the students collaboratively and collectively construct multiple responses. In the name of flexibility, the teacher should monitor closely in case students are presenting incorrect information. The teacher can always utilize techniques from level 1 discourse, like providing additional explanation and filling in knowledge gaps as needed. The top level of discourse is most commonly found in upper level PBL and authentic learning situations. The main difference between level 2 and level 3 discourse is that the students ask the questions and the students answer the questions. The teacher's facilitator role with this level of discourse is simply to encourage students to ask questions of one another to clarify ideas, rather than jumping into the conversations themselves. The last component I want to add to this pedagogy spectrum is inquiry learning, which is another popular pedagogy, particularly in the sciences. I included this toward the bottom of the spectrum because inquiry-based instruction can also be thought of in levels that span the spectrum from more teacher-driven to more student-driven approaches. The earliest form of inquiry learning is confirmation inquiry. The teacher may give students a problem and the solution, as well as the methods to solve that problem so they can confirm the solution. Think of this like a science lab where you study a phenomenon, like what happens when you mix an acid and a base. The teacher may tell you what happens and then give you procedures so you can replicate that effect. A step up from this is structured inquiry, where the teacher presents a problem or question, as well as some procedures to follow so that the students can answer the question. In this level, the student needs to figure out the answer by following those prescribed steps. Many K-12 science labs vary between structured inquiry and guided inquiry. In guided inquiry, the teacher is still the one who poses the question or problem, but the students are the ones who come up with the procedures to solve. Notice where this falls on the pedagogy spectrum. In science class, the teacher may use the phrase guided inquiry, whereas in a math class, the teacher may utilize problem-based learning. Other content areas may utilize other terms that mean something similar. Regardless of the exact word you're using, the similarity here is that the teacher poses a problem, task, scenario, or question, and the students come up with the approach or methods to address it. Finally, in that last box, we have open inquiry, which aligns well with authentic learning. In this situation, students investigate student-formulated questions using student-designed procedures. Notice how the boxes for levels of inquiry do not perfectly line up with the boxes for levels of discourse. This is intentional to remind you that none of the lines on this visual are meant to be solid or rigid. Multiple levels of discourse can be utilized for different levels of inquiry or different pedagogy types on the spectrum. I have designed this visual so that the most common combinations are lined up. You may have noticed that the levels of inquiry do not span the entire spectrum. This is also intentional. The reason for this is that inquiry learning does not match up well with most forms of direct instruction that utilize only level 0 discourse. Big D direct instruction and systematic instruction are best utilized to support foundational content knowledge and discrete skill development rather than to promote student inquiry. Now you see my pedagogy spectrum visual in its entirety, and I hope it will be a good resource for you. Additionally, I hope it will be a reminder that teaching methods we choose should not be random or rigidly locked into just one pedagogical type. Each pedagogy has strengths and drawbacks depending on the learner and learning goal. Expert teachers know how to take multiple sources of information into account to make a decision about the lesson structure, and they also know how to flexibly draw from multiple approaches to meet a wide range of learner needs.